Hello. Good evening, everybody. Am I audible? Yeah, I was waiting to join the people. At least it's good to wait for the others to join, right, people? So I was waiting around 5 to 8 minutes to join other people. Okay, everybody, fine. So I hope my voice is clear and even you are able to see my screen. Yeah, once again, very good evening to everybody. Fine. Did I just say good morning? I don't remember. Out of habit, I might said. Yeah. Good evening, everybody. So in the last session, we started the programming of the LED. I hope you remember what was the topic in the last class. So in the last class, we started writing a code for our first peripheral or easiest peripheral, that is nothing but the LED. So we were started writing the code. So in the last class we discussed that you have a microcontroller. Okay, which microcontroller we are using, people? We are using PIC 16F877A. So to this microcontroller LED is connected, right? So to this microcontroller, let's say like this LED is connected. How LEDs are connected, people? LEDs are connected by using what? Or any external peripheral will connected to the internals of the microcontroller by using what? Rishi, in the last class we started with the programming. First program we started with the coding. So if you missed the study session, if you are not gone through the recorded session or at least whatever video is available on the YouTube, then I think it is a bit difficult to understand the things today. So anyways, you pay attention here and later you even revise the last class, right? Okay, fine. So this is what the LED. Not only LED, any outside external peripheral will be connected to the internals of microcontroller by using ports or by using the port pins, right? So people, how many ports our microcontroller is having? So this microcontroller is having how many ports? It is having the 5 ports, okay? And what are the names? Port A, port B, port C, port D, port E. Am I right? Okay. But people, we got this information from the data sheet of the microcontroller. So a microcontroller is 40 pins, it is 8-bit, and it has a 5 ports and names are this: port A, port B, port C, port D, port E. But guys, let me show you the board which we will be using. So see here. So we are using this board. Okay. So this is your Pixim lab. In that Pixim lab, we are using the PicGenius board. So if you open this Pixim lab, so by default, you might be able to see this Arduino board. So here you see a lot other menus are provided here. So if you go in the board menu, so here is the list of different boards. So in among these board, we are using the PicGenius board like this. Okay. Now people, if you see this board, so this board is having multiple LEDs. Let me show you by highlighting. So how many LEDs this board is having? It is having the multiple LEDs. Okay. Now question arises. Okay. Question is what? From the data sheet we got to know there are the 5 ports, but guys, my question is, are we still clear to which port LEDs are connected? Let's say you have a total 16 LEDs right now in your board. So do you have any idea how where the LEDs are connected? Like this way, total 16 LEDs are there. Those are connected to the microcontroller board. So do we got that idea just by looking at the data sheet? Don't you think that question is still unanswered? So in the last session, we just got to know microcontroller having the 5 ports. Okay, now how do we know whatever connections are done on this board, how these connections are done? What is the how the connections how are done for this board? So what we need to refer here? So guys, you have to refer the schematic of this board. Is it? Sound is not there? Guys, am I not audible? Yeah, please check your connection. China Adike, you're saying no sound. I think there is an issue from your side. Please check your connection. Yeah. So what I was saying, so now to get that answer, what we have to do, we have to check the schematic of the board. So schematic is a document in which how the connections are done on the board. That picture is mentioned. Now you downloaded this, okay, so you what you did, you loaded this pixim lab. Now if you wanted to see the schematic of the board, I will guide you how to download the schematic. Now people pay attention, you do this later. So you have to go to the help section and then directly select the board. Now it will navigate to this page. So right now which board is loaded? PicGenius board. So if you see my screen, on that screen PicGenius board is there. So automatically as soon as you click on the boards, it will navigate to this board. Otherwise, if you're not able to see, you can see here is the list of boards. So depending upon which version you are using, this list may vary. But anyways, PicGenius is there, you can select that. And as soon as you scroll down, if you come down, are you able to see? They are mentioning about the board schematic, board PicGenius schematic. Fine. Now people, let me click here. So here is the schematic diagram of my board. So you can download the schematic diagram and keep it ready. But if I'm not wrong, if you're not able to do that, if I'm not wrong, even the same schematic also uploaded in the documents or material provided to you. So you can check even in the LMS documents. Okay, fine. Now pay attention here. So now if you see, okay, now here you can see schematic. If you see, here is your microcontroller. How many pins you are having? You are having the 40 pins as mentioned here. And guys, thing is what? It's not possible to show all the connection together to this microcontroller pins. So what happened? They did the aliasing. What do you mean by aliasing? Means, for example, you see here this connection. So here, are you able to see? So they are mentioning that this pin is connected to the RC3. So wherever you see the similar names, connection is towards that pin. Means, for example, you see here RC3. So where it is connected? The connection is here to the RC3, like that. So wherever you see the same pin numbers, if you see these numbers here, RD0 to RD7, so where is the connection? So directly these pins are connected here. So many components are there on board. So it's, if you are going to see the one single pictures diagram to show the connection, literally it will be chaos, right? So aliasing is done. So if you see the same name, that means your connection is towards that particular pin. Okay, now if you see the board, so if you see this Pixim Lab board, PicGenius board, it is having 16 LEDs. So you can see this is LED array 1, this is LED array 2. So total how many LEDs are there? 16. Now let me directly jump to the schematic and show you this LED. So at least all of you are aware with the symbol of LED. Everybody, I hope you all are aware with the symbol of LED. Even we discussed that in the last session, right? So without this double arrow, it's a diode. With this, it is LED. Am I right? Now don't you think this is what your LED? Am I right? These are the LED. Are you able to see? Here are the 8 LED set. Here is the another set of the LED. So total, are you able to see the 16 LEDs here? Total 16 LEDs, are you able to see here? Yes, we can see. So here you can see you have a two LED array or two set, one set of 8 LEDs, another set of another 8 LEDs. Okay. Now let me talk about the first array. Array I am referring because I'm considering this as a kind of set of 8 LEDs. So I'm referring this term as an array. Now let me talk about the LED array 1. Okay. Now people, you see here you have a LED array 1, or you can say the LED set. So if you pay attention here, everybody, if you pay attention and let me know, let's first talk about the array 1, set 1. So may I know where to which port this LEDs are connected? To which port of the microcontroller this LEDs are connected? Very good, Manjunath. What about others? Does Manjunath have a habit to use the proper naming, use the capital letters to mention the ports? Just have a habit. Guys, are you able to answer where the array 1 LEDs are connected? Don't you think it's a port D? Very nice. See here, the pins RD0 to RD7. These are the which port pin? Nothing is like just a D. I'm sorry if your answer is just a D. No. So this LED is array 1 if you talk. So this pins, what are the pin numbers? Pin namings for the port D. It is from RD0 to RD7. We saw in the last class, right? Nothing is like port 1. Sorry, Vaishnavi. Nothing is like RD Zoshi. I'm so sorry. Your answer is absolutely wrong. Nothing is like a D port. Have a habit to use a proper naming. If you are going to do the coding without these names, then it's wrong. Rishi Zoshi, you please go through the yesterday's class. We clearly discuss all these things. So right now, if I'm going to repeat it again, we will be investing lot of time. So you just go through that session. If you have still issue, we will see you once again. Fine. Chalo. So where it is connected? So shall I conclude? It is connected to the port D. Am I right, everybody? So it is connected to the port B. So one each LED connected from RD0 to RD7. Everybody agree? Everyone, are you agree with me? Now, let me go to the another array. So if I talk about the another array, let's say this one. So where the another array is connected? Everybody, where the another array is connected? Where it is connected? See the LEDs, LED1 to LED8. From the another array, what are the pins? RB0 to RB7. So where it is connected? Port B. Simple, yes? See, you literally are able to follow the schematic and you are able to answer all the questions. How easy it is. Nice, nice, very good. So where it is connected? It is connected to the port B. So LED array 2 connected where? To the port B. Okay, very nice. To which pins? To the pins RB0 to RB7. Have a habit to use the proper naming always. Fine. Now, chalo. Now let's take only one array just for the sake of example and proceed further. Now let me give you the requirement. My requirement is saying that turn on the LEDs, okay, connected to port B. That means LED array 1 or port D. Let's go ahead with the port D. So what it is saying that turn on the LEDs connected to the port D. Fine. Now people, roughly, if you see the picture here, I will be talking about this in detail. But don't you think to turn on the LED, you have to give some data to every bit from RD0 to RD7? Am I right? So if you see here, what you have a port D. Okay, port D. So how many bits port D is having? 8 bit. Let me show you the bits here. So RD7 is nothing but the MSB bit of the port D, right? Then there will be RD6, okay? Then there will be the RD5, okay? Then there will be the RD4. Then there will be the RD3. There will be the RD2 bit and RD1 and RD0. If I'm missing or if I'm doing anything wrong in between, please correct me. So you can see RD0 to RD7. Now people, in the last session, we discussed that to turn on the single LED, okay, with respect to single LED, to turn it on, what we have to load? We have to put the 1, or to turn it off, we have to put the 0. We have these assumptions. Why? We will see. Now here guys, so I have to turn on all the 8 LEDs. So don't you think I have to put 1 to the RD7 as Sohan is saying? Don't you think I have to put the 1 to the RD6 like this way? All the pins I need to provide the 1. Am I right? Everybody agree? So that all LEDs will be 1. Yes or no? Yes or no? So what it will be? Everybody, are you agree? You have to give the input like this means. So here you have to put what? This is one like this you have to put. Then it will be on or LED will be, let's say, on like this. Now my question is, let's deal with the X number. Let's deal with the X number just for the sake of simplicity. So now what hex number I need to load in my port D? Don't you think it is 0xFF? This is binary values, right? 1. So what hex number we have to store? 0xFF. Decimal, I feel it's difficult. So go with the hexadecimal number, it is 0xFF. Correct? Agree everybody? Fine. Now this requirement to turn on the LED is connected to the port D. Let me write the code here. Now see here. So what is my program? Let's say void main. Okay. Now what I did, I'm doing here. Let's see integer port B. Okay. Then I'm sorry, it's a port D. We are not dealing with the port B. Let's say port D I'm using, fine, no problem. Then I will be writing port D equal to 0xFF. That means here I'm putting, if you talk about the binary value, all bits I'm setting as a 1. So what do you think? It will turn on the LEDs? It will turn on the LEDs? Okay, Harsh, I will talk about that. So answer my question, others, which it's going to turn on my LEDs? Yes, no, yes, whatever is your answer, feel free to answer. Even if it is wrong answer, who is going to judge you here? You are here to learn the things, right? Yes or no? Okay, so whatever is your answer, you can please talk about that. Fine. Okay. Everybody, please speak. Okay, so actually, thing is what to start with now. Actually, if you open a data sheet and if you see now, as compared to other ports, detailed information about the port B is written. So now let me repeat the same thing with the port B also. Okay, now see, fine. So this is we discuss about the port D. Keep it that aside. Now let me update the code for the port B. Now let's say I want to turn on the LEDs connected to the port B. So what will be the changes here? What will be the, how many pins port B is having? How many pins port B is having? How long it is? How long it is? 8 bits. So what are the names? You will be having here bits from the RB7 to RB0. Am I right? So here, if you see, just a second, let me complete this. Whatever your questions are there, I will answer all those. Let me just complete it. Give me a few seconds, fine. Okay, so this is about the port B bits from RB0 to RB1. Okay, now see here. So now to turn on this, okay, to program it, what I will be doing. So obviously here also you have to put the 1. Okay, now what I'm doing, guys, just be little patient. I will be answering all your queries, but just be little patient. So now here, if I updated port B like this, and if I'm putting 1 to the each bit of the port B, so what do you think? It is going to start my LEDs. So again, few of you may say answer is yes, it will. Few of you are saying the no. Now, I have a question. I have a question. This port B, whatever I am talking, it is a port of this microcontroller, is it? It is a port of this fellow, it is a port of this microcontroller. If you see the diagram or if you see the whatever program we written, what is this port B? What is this port B, people? Pay attention, look here carefully. What it is just an integer variable, isn't it? So previously here, if you see the last code, there was an integer variable LED. Am I right? So I just replaced the name of that variable with the port B. So is it become the port of our microcontroller? Obviously no. right? So guys, so to turn on the LED, you have to write where? To the port of the microcontroller. But before that, so basically we have to program the port B of the PIC16F877 microcontroller. Then don't you think, so before programming that port, it is always better to read the information about the port. Am I right? From where? From the data sheet. Now you can see here my data. I'm opening the data sheet here. So you see the table of content. Now, as I said in the last class, what? Don't read everything. Whatever you want, just get that information and implement. So can you help me here? Now for the port B, for the port information, which section I need to refer? What do you think, people? Can you guess? Fourth section. Very good, Kusuma. So if you see section number 4, you have to please refer, see here. So let me show you. Let me just open this section completely. Section number 4. Now in this section number 4, if you see, section 4.2 is nothing but the subsection for the port B. Now everybody, carefully, can you please read the first paragraph regarding the port B? Everybody, can you please read the first paragraph regarding the port B? And once you are done, let me know. Just read the first paragraph. This much information is fine to program the LEDs. Do it and let me know once you are done. Whether you are understanding, not understanding, just try to read carefully. And once you are done, let me know. Done, everybody? Now I will explain whatever is there. So your work is done. You gone through this first para. Everybody, can we discuss now? Okay, chalo then, pay attention. So if you see this section, so regarding port B, they are talking about the now guys, don't ask me the question now, just be little patient. Now we are discussing the same thing, right? See here. So now if you see here, so this section is talking about the port B, and you know, with respect to the port B, they are mentioning the some register B also. So from this, what we are understanding, if we are planning to program the port B, then what we have to do, we have to program the TRISB register. So okay, that information we got from the data sheet. Now pay attention. So what they are saying, they are saying that port B is a 8-bit byte and it's a bidirectional port. So guys, whatever information we collected yesterday from the block diagram, it is matching. That's what we concluded the regarding port B from the block diagram, right? So how much is the size of port B? It is 8-bit wide and all the ports are bidirectional, right? That's what the information also we collected. Fine. Now pay attention. Next important thing. There's, by the way, can you see my screen? It is getting updated, guys. I'm changing the screen. I think it is stuck. Oh, let me unpause it. I think now it is fine. Now let me repeat. See, what I was saying, see, with respect to the port B, there is a TRISB register. So whenever you're planning to program the port B, you have to program the TRISB register also. And then later, if you start reading about the port B, they are saying that port B is a 8-bit wide and it's a bidirectional port. So guys, from the block diagram of the microcontroller, we got the same information, right? So port B is how much long? 8-bit wide, and it is what? Bidirectional, right? So same thing here also mentioned. Now let's read further. So what they are saying, they are saying that the corresponding data direction register is TRISB. Okay, now people, in general, when you talk about the PIC microcontrollers, to give the direction of the PIC microcontroller pin, there is a TRIS register. What is the name of the register? There is a TRIS register. TRIS stands for the tri-state. Okay, so basically it is having the three states. Okay, one is nothing but the three states basically. One is nothing but the input high, then or output high or output low, or the high impedance state. So basically what you have to do, by using this trace register, you can set the direction to the pins of the PIC microcontroller. So TRIS stands for what? It stands for the tri-state. Okay, fine. Now, what we have to do, as I said, in case of PIC microcontroller, every port, not only this port B, every port has a directional control register. So you can refer this TRIS register as a what? Direction control register. Fine. So even you might see the say registers in other microcontroller with other name. That's fine. So here focus on our microcontroller. Fine. Now here, this, as I said, this stress stands for the stride state. And what are these three states? There will be output high state, there will be the output low state, or there will be the high impedance state. Okay. So it is what? A directional control register, which is nothing but the TRIS. It is stands for the tri-state. It has a three-state: output high, output low, and high impedance state. Now, if you read the data sheet, okay, regarding the port B, so what they are saying with respect to port B, what is the name of the TRIS register? Now see, this register names varies, register names varies from ports to ports. Means I think now my screen is okay. Now see here, if you have a port A, so what is the name of data direction register with respect to port A? So just this TRIS X will replace with the last name of the port. What will be? It will be TRIS A. So in general, I'm talking, if you have a port B, what will be the data direction register name for the port B? TRIS B. Am I right? If you have a port C, what will be the name of data direction register? TRIS? Speak. X will be replaced with the Zoshi. You're messing up the things. I'm so sorry. Your answer is not acceptable. So whatever you are talking, you are talking with respect to other microcontroller. Forget those things. So focus on which microcontroller we are studying. So terminologies might be different for this other microcontroller. That's totally fine. So refer what we are talking. So what it is? Trissy. Don't get confused, and even don't confuse others. What about the port D? What will be the name to give the direction to the port B pin? So we have to, while programming, as many of you said earlier, we have to give the direction either input or output to the port pin. So how we can give? By using this directional control register TRIS. Okay. Then one more port is the port E. What will be the name? It will be TRIS. X will be replaced with the E. Am I right? Use the capital letters, Manjunath. Fine. At least you got the idea about the TRIS register, everybody? Okay, now let's talk about the port B trace register. Fine. Now people, so with respect to port B, to give the direction, we are having which register we are having? Trace B register. Fine. So let's discuss the things from the port B register point of view. Why? Because we are programming it. Now here we have a trace register. Okay, so basically see here we have a port B like this. Okay, everybody, and to give the direction to these port B pins, there is a trace register. So how long is this trace register? It is also 8-bit. And what are the different bits of the trace registers? If you talk about the different bits of the trace register, it is also having the 8 bits. What are the names? You can consider like this. This will be the MSB. Okay, so let's say this is what Frisbee 7. I'm sorry guys, I'm writing everything for you. No Kusuma, don't miss this. TR7, no, Frisbee 7, Frisbee 6, this will be Frisbee 5, this will be Frisbee 4, this will be Frisbee 3, this will be Frisbee 2, this will be Frisbee 1, and then here is the MSB bit, which is nothing but the Frisbee 0. Now guys, this trace register, either you can have a bit access or you can have a byte access. Fine. Now let me go to the data sheet and let's read the further things. Fine. Now see here. So what the data sheet is saying, people, to set the port B pin as a input, what should I write in the trace bit? What I have to do? I have to set the trace bit or I have to clear the trace bit? To make the port B pin as output, what should I do? So what they are saying that setting a port trace B bit means if you are putting the trace B bit as a 1, setting means 1, clearing means you are making it 0. So usually what you did, if you set the trace B bit as a 1, okay, individual bit you can access, then what happened? Then what direction you are giving? Then you are giving the you are making the, what it will do, it will make the corresponding port B pin as a input. What it will do, corresponding pin will be input. Fine. Now what about the output? If I'm doing the opposite of this, if I'm clearing the trace B, okay, not setting, if I'm clearing it means if I'm putting this as a 0, then what happened? What the data sheet is saying, so if you are clearing the trace B bit, then it will make the corresponding pin as a output pin, an output pin. Okay, fine. So based on the peripheral which you are working, you have to give the direction either as the input or the output. Fine. But we understood for the input it will be 1, for the output it will be 0. Let's have some test cases, people. Now, if I'm writing, everybody see here, if okay, if I'm writing trace B, okay, equal to let me use the binary number. So guys, how to represent the binary number? How to represent the binary number? Like this, it will start like this, B for the binary, right? If I'm writing 0, B 1 1, or and then 1 1 1. So what I'm doing? Don't you think entire trace B register, I'm putting all these 8 bits as a 1? All 8 bits as a 1? Agree? Yes? No? Mm-hmm. Okay, now what is the hexadecimal number of this all one? What is the hexadecimal number? What is the hex value? I hope you're good in the hex Baba. 256 is a decimal number. I'm asking for the hexadecimal. Yes, for the binary Neha, it is compulsory. If you don't know the number system, revise it once. So let's deal with the hex number. Let's say 0xFF. So this is FF is not hex. 0xFF is the correct representation. So don't you think, people, instead of representing in the binary like this, it is better to go with the hex number? Are you agree? Many of you were asking why FF. I was just representing 8 ones of binary with the FF. Don't you think it is better? So let me remove this binary. Let me put like this. So 0xFF means what? All ones. So what I'm doing? all the bits of the twist register I'm setting like this, 1 1 1 1, correct? So this will be 1 like this. So here all are I keeping this one, this will be 1, this will be 1, this will be 1, this will be 1, okay, this will be 1. So now, okay, so what will be the direction? Direction will be input or output, people? Port B direction will be the input or output. One is for what? For the input, right, everybody? One is for the input, okay. Now if I just wrote, if I just wrote now trisby 3 equal to 0, then what? First of all, let me know what will be the direction, input or output. It will 0 is for what? Output. Now let's try to understand here. So if you are using the single bit, or usually what is the meaning of this line? It makes the corresponding port B pin. What do you mean by corresponding pin? Now pay attention. So here trisb0 is corresponding to rb0. It is used to give the direction for the rb0. trisb1 is used to give the direction to rb1. Same way, trisb2 is used to give the direction to rb2. trisb3 for the rb3, trisb4 for the rb4, trisb5 for the rb5, trisb6 for the rb6, trisb7 for the rb7. So by putting the trisb3 equal to 0, which pin of the port B I'm setting as the output? Which pin, people? Can you give me the name of the pin? Which particular pin I'm setting as the output? It is nothing but my RB3. Understood what is the meaning of corresponding pin? And even if you are writing something like this, trisb6 equal to 1. So which corresponding pin I'm making as input here? Which corresponding pin I'm making as input? Give the name, proper name, Kusuma. It will be RB6, right? Na. Trisby 6, I said, na. Who is there with respect to Trisby 6? It is RB6, am I right? Or even, let's say if I'm writing like this, let's say byte axis I'm having Trisby equal to 0xf0. Okay, if I wrote 0xf0, means what is the binary of it? It is going to be 1111 and 0000. Now you have to answer properly. So here, few pins I'm putting input, few pins I'm putting output. So which pin are going to be input here? Among this data, which pin? This is LSB by this is LSB bits. These are the MSB bits. So which pin are going to be input? In this case, which pins are going to be input? Don't you think RB4 to RB7, these pins are input? Correct. Whatever you said, RB7 to RB4. Very good. Nice. Then what about the output pin? Which pin are output? Give me the naming. Those are from RB3 to RB0. Great. Understood about the test register, how to deal with it. Now it will be output or it will be input, we will see. Up to this you got the clear idea about what they are mentioning in this data sheet. Understood? Many of you were asking what is stress, what is stress B, what is 1, what is 0. I explain everything in detail. Are you clear, everybody? Okay, fine. Now what we will do, let's do the proper programming now without any assumptions and all this thing. What we will do, so let me discuss few basics. You might be aware with those basics, but let me just revise those basics. Okay, so pay attention, everybody, please have a full focus here. Okay, now see, Neha, what you will be right. Yes, it is better to write RB0 to RB3, but since I got the responses like that, so I wrote. So anyways, even you can write accessing the separate bit also. RB0 to RB3 is the correct way to mention. Fine. Now everybody pay attention. Now we will be doing the actual programming of the LED. Pay attention everybody. See here. So let's clear some basics before going into the programming. So what is this on your screen? Whatever symbol you are able to see, it is a symbol of what? Everyone? Diode. Okay. How many terminals diode is having? How many terminals diode is having? Two terminals. One is anode, other one is cathode. Positive, negative terminal. Fine. I hope everybody agree with this simple statement. Then let me go to the next slide. What it is, everybody? Whatever you are able to see on the screen, here you can see now. Pay attention now. Don't say diode. So here two arrows. Are you able to see it is LED? So what is the difference between LED and diode? What is the difference between LED and diode? So basically, LED is the same like diode, but what happens when current flows through the LED, it emits the light. This is the only difference between the LED and diode. Okay. Now, in general, if you see the second connection circuit, what it is again LED. Now, if you see the connection circuit, to turn on the LED or diode, let's see the diode first. To turn on the diode, how do you need to do the connection? I mean, we have to connect the our diode in the forward bias or it is in the reverse bias. Which is the correct way of doing the connection? I'm just revising it. You know all this thing. So obviously you have to do the forward bias connection, right? Those who are confused with the forward bias, for them in simple word, you have to connect what? Positive terminal to positive and negative terminal to negative, then it is forward bias. If it is opposite, if it is ulta, then it is what? Reverse bias, right? Now, to turn on the diode, how the connection you have to do? You have to do the connection in the forward bias. Same for the LED also, right? Same thing for the LED also. Agree everybody? Fine. Now let's see this picture. So now this is what? This is my LED. Okay. Now if you see here, if you see that this LED, so what happened? So this terminal is positive terminal, this terminal is negative terminal. So now pay attention here and let me know what type of connection it is. It's a forward bias or it's a reverse bias, guys? Yeah, it's a forward bias, absolutely right. Positive to positive, negative to negative. So what happened? Will this LED turn on? If I'm doing the connection like this, it is going to turn on my LED. If I'm going to do the connection like this, it is going to turn on my LED. Obviously, yes, it will turn on the LED. But people, are you able to see any issue in this circuit? I mean, don't you think if we do the connection, this type of connection, we may end up by damaging our LED? What if more current is flowing through the LED? Don't you think probably with this type of connection, we will end up by burning our LED? Isn't it? Yes or no? So what we have to do? What we have to do? Don't you think here, guys, we have to limit the resistor? I mean, we have to limit the current at least by putting the resistor. Yes, no? Yes, you need to add the resistor. Fine. Great, great. Now, which side I have to add the resistor? You all are agree with me. Whatever you are saying, I'm agree with you. But to which side I have to add the resistor? I mean, towards the positive side of the LED or the towards the negative side. Just be careful, whatever you are saying to your statement. Where we should add? Toward the positive or the towards the negative side? Now see people, first of all, I'm not expecting this answer from everybody. Okay, Gopinath, very good. Others or Rahul, very good. Now see here. First of all, my simple question is, how are we going to add the register? Are we planning to add the resistor in series or the parallel? Are we planning to add the resistor in series or in the parallel? We are adding in the series, right? So does it matter in case of series connection? Does it matter where we add? Don't. Now see, many of you are thinking, I know how the students response is. So many of you are thinking that if I'm not adding the resistor here, if I'm adding the resistor towards the negative side, then first current will flow through the LED and then later it will be limited by the resistor. No, not true. Doesn't matter in your series. Wherever you add the resistor, how does matter? So total whatever resistor is there, it is going to what? Limit the current, correct? It's a series now. Throughout the series connection, same current is going to flow. Am I right? Come on, you're still in your engineering basics, basic KCL law, right? So it doesn't matter when you are in the series. So can I say you can add anywhere? This is the correct answer. You can add the resistor anywhere. Let's say I'm adding here. Now is this fine circuit? Is this fine? You can see it's a forward biased connection, positive to positive, negative to negative, no issues. I'm adding the resistor to limit the current. Okay, great. So everybody, do you have any issue with this? Understood? Everyone? Are you clear with this? Fine. Now I have a slides. Okay. Now let's discuss the same thing in the slides. Fine. Now, if you see my slides, okay. Yeah, here these are the slides regarding the LEDs. Okay. So what these slides are saying that, now see here, they are saying that LED is nothing but the simplest device used in the most of the embedded system as a feedback. Mostly we are using LED as a feedback device, and it works exactly like a diode, right? And it has many advantages like lower energy consumption, it has a longer life, and smaller, obviously LED is in very small size, correct? And it's a faster switching. So these advantages make it usable in the many applications. A few applications are mentioned here. So nowadays you see the LEDs in the home lighting, even your remote controls, or many displays also the LEDs are there. Now if you see my next slide, everybody see, this is my LED. Now pay attention here. Now guys, this is my switch. Okay, so now if I press the switch either this side or either this side, if I press the switch, what do you think, which connection is going to be there in the forward bias, or which LED will be on? If I press the switch, let me give the numbering. The circuit 1 of this first LED, or the circuit 2 or the LED 2. Which LED is going to be on? If I press the switch, what do you think? What is your answer, everybody? Take some time and answer. Second one, okay. Most of you are saying second one. Okay, now don't copy somebody else answer. Whatever is your answer, answer it. Fine. Okay, now anybody is struggling to find out which one is positive terminal, which one is negative terminal of the LED? Few of you might be struggling, right? Which one is positive, which one is negative terminal, because it's not a symbol of the LED, right? Now see here. Okay, let me show you that also. Just a second. Yeah, so let me go here again. Now if you see, if you're not aware which leg of the LED is positive, which one is negative, you refer this picture. So now whatever is the longer terminal, it is what? Whatever is the longer leg, it is nothing but the anode, positive terminal, and shorter one is the negative. Fine, now take help of this and now try to answer. Those who are struggling, you can answer longer leg is nothing but the positive one, shorter one is nothing but the negative one. Now see, if you see this is the positive, this is the negative. So positive is connected to the negative, negative is connected to the positive in case of first circuit. So it is forward bias connection. No. So if you press the switch, if your answer is 1, it is wrong. 1 will not work. Now let's go to the second case. If I press the switch, see here, longer leg is positive terminal, shorter one is negative. See here, Positive to positive, VDD means higher end. Positive to positive and negative to the negative. That means ground is considered as a lower voltage, right? Now, don't you think second one is forward bias, right? So, second, those who answered the second LED, yes, absolutely, your answer is correct. So, if you see, observe here. If you press the switch 1, if your answer is 1, it's wrong. But if you press the switch 2, see here, second LED will be glowing. Understanding? Fine. Now, okay, still now, do you have any doubt? Anybody? Do you have any queries till now? Anyone? Okay, it's very, I'm creating a base. It's a very simple topic. Now see, let's see. Now let me talk about the onboard connection. Fine. Now see people, let's say you have a LED. So how many terminals LED is having? In case of LED, how many terminal LED is having? It has a two terminal, right? One is nothing but the anode, okay? Other one is nothing but the cathode, negative terminal, right? So how the connection will be done? Since it has a two terminals, you can do the connection two ways. What is the first one? Let's say this is your microcontroller, okay? Let's say this is your microcontroller, fine. Now people, so what happened? Let's say or I think I have a picture of it. Instead of drawing it, let me use the same picture so that we can see you sometime. Just a second. Yeah, so here it is. Pay attention. So if you see this, people, you can see this is the connection. So see how many terminals LED is having. It is having the two terminals. This is anode, positive terminal, negative terminal. So if you see the connection, so positive terminal, that means anode is connected to what? To the microcontroller pin. Let me give the name to this pin as a RB0, where it is connected to the, let's say, RB0, since we know LEDs are connected to the port B also. So let's take the one pin RB0. So now people pay attention. So now I have a question. To turn on this LED, what type of connection we have to do? We have to do the forward bias connection. So if you see this diagram, if you see this connected, already negative terminal is connected to the negative terminal, lower end is connected to the lower end supply, no problem. So now, so this to turn on the LED, okay, what should I write to the port B pin, that is RB0? What signal I have to provide to the pin RB0 to turn this LED on? And as I said already, in case of digital signal, your VDD, your VSS 5 volt is represented by the 1, and your 0 volt, your ground, it is represented by the digital value 0. So now talk in terms of 1 and 0. So to turn on this LED, what should I provide to the pin RB0? It is just a single pin. It's just a single pin RB0. So what should I write to the bit RB0? I have to put the 1, right? If I'm putting here 1, see here. So now, if you are seeing the 0. So if I'm writing a 0 here, connection is going to be forward bias? Obviously no. But if you put here 1, let's say here I'm writing a 1. Don't you think this positive terminal will be connected to the positive, negative to the negative? Now, if connection is like this, then current is flowing outside through the LED, outside of microcontroller. Agree? And the LED will be on. Now people, I have a question. So in this, so here to turn on the LED, you have to put the 1. Okay, so now in this type of circuit, what happened? Who will be the source of current? Don't you think microcontroller is going to be the source of current? Yes or no? Don't you think, since you are writing a 1 to the microcontroller, what happened? What it is doing? It is what? Uh, it is generating the current, right? Yes or no? Fine. Now guys, yeah, fine. Yeah, let me note down these things. What I mean, yes, who is the source of the current? Microcontroller is the source of the current. Fine. Now this type, since microcontroller is the source of the current, this type of circuit is referred as a current sourcing circuit. Fine. Who is the source of the current? Microcontroller. So let me note down these things for your reference. So here if you see, since microcontroller is the source of the current, it is referred as a current sourcing circuit. Fine. Now in case of current sourcing circuit, people, okay, to turn on the LED, okay, if I'm doing any type of mistake, please ignore. Now to turn on the LED, what should I write at microcontroller pin? Doesn't matter whichever pin is there. So here we are having RB0. So to turn on the LED, what we have to write at the microcontroller pin? We have to write the 1. Agree everybody? Then only connection will be in the forward bias. So to turn off the LED or to keep it off, what should we write? We can write the 0. Agree? So here if you see, if you are putting the 0 here, okay, then what happened? Connection is going to be there in the forward bias? Obviously no. If you are giving a signal 0 here, no forward bias connection. If you are writing what, your RB0 equal to 0, there is no forward bias connection, no current will flow through the LED, and what happened? It is not going to glow. So what you have to put? To turn on the LED, you have to put the 1, and to keep it off, you have to put the 0. Agree everybody? Fine. Now let me talk about this microcontroller pin direction. Okay, you have this pin RB0. Fine. What will be the direction of the pin in case of LED? Now see. So what is happening? So this is positive terminal, negative terminal. So don't you think this microcontroller via this port pin RB0 giving signal out to the peripheral LED? Either 1 or 0, it is giving out to the LED peripheral. Means if I'm putting 1 here, it is going to be input to the LED, and LED will glow and current will flow, right? So don't you think this microcontroller is giving something outside? Agree? So what will be the pin direction? So if it is going out input to the external peripherals, then pin direction is going to be output pin. What will be the direction, people, in case of LED? It is going to be output. Yes, no, understanding? So when you are going to set the direction of the pin in case of LED, that pin direction is going to be output pin. You have to set the LED pins as a output pins. Fine. Port pin, microcontroller port pin. So always we are setting the direction with respect to microcontroller. Fine. Okay, so this is one way of the connecting the LED. Fine. Then what could be the another way? So let me come to this circuit. So if you see here, so in this case, how the connection is there? Opposite of previous connection, right? So if you see here, this is what? Negative terminal, this is the positive terminal. So this side, this time cathode is connected to the microcontroller. Okay, let's say this is RB0. So now people, what happened? Already VCC or VDD or the 5 volt is connected to the positive terminal. So don't you think in this type of circuit, to turn on the LED, what you should write at the microcontroller pin? What signal I have to give to make the circuit forward bias and to turn on the LED? I have to give the signal 0, right? Very good. You are putting the 0, then only it is forward bias. You have to write the 0. So as soon as you are putting here 0, are you able to see? Current will be flowing like this. So now, if I talk about the direction of the current, don't you think, people, the current is flowing towards the microcontroller? Don't you think, people, microcontroller is accepting the current? Don't you think, guys, microcontroller is sinking the current? Yes or no? So this type of circuit, due to that, since microcontroller is sinking the current, this type of circuit is called as a current sinking circuit. What it is called as? It is called as a current sinking circuit. And guys, in case of current sinking circuit, what you should write to the microcontroller pin? Opposite of the sourcing circuit. So now in this case, to turn on the LED, what signal you have to give at the microcontroller pin? 0. And to keep it off, you have to write the 1. You can see once again here. So to keep it off, you have to write the 1. So if you are putting the signal 1 here, the connection will not be in the forward bias, LED will not glow. Fine. Now, let me talk about the onboard circuit. How connection is there? Connection is done. So here, yeah, here you can see this connection on board circuit, whatever you are having this, or even I mentioned the same circuit where here also in my data, in my slides, you can even you can refer this same one and the same. Now people, if you pay attention here, let's focus on the first LED array and let me know what type of circuit it is, or both the connections, see both the LED arrays, and let me know on board whatever connection is done in this fixing lab already, it is what type of connection? It is current sinking circuit or it is current sourcing circuit? See here, this side will be connected to the microcontroller. This is positive, this is negative. Negative is connected to the ground. Same for the another set also. Yes, what type of circuit it is? On board, you have now above both are sourcing. See the second circuit also. This is what microcontroller port pin. If I'm drawing like this, here also microcontroller. Don't you think same connection, right? Positive terminal. That means anode is connected to the port pin and negative is grounded. It is what? Current sourcing circuit. So on board means whatever fixing lab board we are using already, the connection is done in terms of sourcing circuit. So at least for now, do we need to worry about the syncing circuit? Do we need to worry about the syncing circuit for this fixing lab board? Already connection is done. Can we change that connection? Can we modify those connection? No. So don't worry about the syncing circuit. So focus on the current sourcing circuit. Pay attention. Now everybody. So let's say I want to turn on this LED 1. So what should I write my pin RB0? Syncing means, in simple term, Vigneshwar, it is microcontroller is syncing, absorbing, accepting a current. But anyways, we don't have a syncing circuit. Observe here on the, pay attention on the sourcing circuit. Fine. Chalo. So to turn on the LED 1, what should I write at my RB0 pin? 1. Then it will be on. To turn on the LED 2, what should I write to the RB1 pin? 1. To turn on the LED 3, I have to put the 1. So basically, if you are putting the 1, LED will be on. Okay, now see, if I want to turn on all the LEDs connected to the port B, then what should I write to the port B, people? If I want to turn on all the LEDs connected to the port B. So what number I can write in the port B? Together 8-bit number. Can you give me that value? So RB0 to RB7, all bits are going to be 1. So don't you think it is going to be 0 except F? Making sense? Now, those who were saying, ma'am, why 0 XFF? Why 0 XFF? Understood? Your question is answered, guys? Now same thing for the port D also. See here, those who had a question, please do respond. So I will get the idea whether you're clear or not. Same thing for the secondary also. Now if I'm putting, let's say RD0 as a 0, what happened? The LED1 will be on. LED1 will be on. If I'm putting RD1 as a 0, no, that will be off. If I'm putting this one, it will be on. If you're putting 0, it will be off. If you're putting 1, it will be on. If it is 0, LED5 will be off. So basically, if you focus here, basically, in case of current sourcing circuit, what happened? In case of current sourcing circuit, that's why I noted the things for your understanding. Now that's why what happened? So we have to focus here. So to turn on the LED, what you should write at your microcontroller pin? 1. Okay, chalo. Now finally let's do the programming. Can we go ahead with the programming, proper programming? Now previously we had some assumptions, we had assumption like to turn on the LED you have to put the 1, to keep it off you have to put the value 0. I hope it is clear now. I hope all this assumption is clear now. Fine. Now let's turn on the LEDs connected to the port B. So now let me go here. Fine. Now see here. So let me take one more variable which is nothing but the trisby. Now don't you think people, now you have to first give the direction. We got to know from the data sheet with respect to port B there is a trisby register. Now we are using the LED. So to work on the LEDs, what will be the direction of the pins? What will be the direction of the pins? I'm using the port B pins. What will be the direction of these pins? You have, don't you think you have to set all the pins as the output? Entire port B you have to set as the output. Always whenever you are using the LED you have to set that port as the output. So what should I write in my trace register? So can I load the value like a trace B equal to 0x00, and then 0 is also fine, 0x00 is also fine. Just to give you the feel of 8-bit, I'm putting 0x00. So it will, what it will do, it will set port B as a output port. So I'm giving the direction as a output port. Fine. So many of you are saying that, ma'am, direction of the port is not given. That's why code will not work. I hope your answer question is answered. So we are setting the port B as output port. Fine. And then after setting the port as output port, I'm giving the direction. I'm writing port B equal to 0xFF to turn on my LED. So as we just now we saw that from the onboard circuit, to turn on the LED you have to put the 1. Since I want to turn on all the LEDs from the pin RB0 to RB7, I'm putting 1. So this program is going to turn on my LED. Is this program is going to turn on my LEDs? Will this code work? I feel yes. What about you? Will this code work? Okay. Others? Come on. Everybody's opinion matter here. What about other people? Come on. Those who are watching this, let me know. Will it work or it will not? See, again, I just played a small trick. Many of you were seeing the yes. See here. Again, whatever I declared here, port B and tris B. What it is, people? Port B and tris B. What it is? Don't you think these are just integer variables? These are just integer variable, isn't it? Yes or no? So these variable are the registers of our microcontroller. These variables are whatever register this microcontroller is having. These variables are the register of this microcontroller. No. So these are just integer variables. So people, so what we have to do? So now we have to open the data sheet and we have to check what is the address of the particular ports, and then we will be writing to that address. Okay, now here is my data sheet. So to be honest, I don't know where to refer addresses and all this thing. So what I will do, directly I will search for the port B address. Fine. So let me just search for the port B. So fine, lot of results I'm getting here. If you observe, port B. See here. Let's go through many results. Let's wait. Still we are getting the addresses. Okay, this is not one, not this one. Yeah, here is my register map. I'm interested in this. I got it. Fine. Now here we are having many register banks. So just focus on first two, bank 0 and bank 1. So what is the address of the port B register? What is the address of the microcontroller port B register, people? What is the address of the microcontroller port B register? It's a 0x06. What is the address of the TRISB register? 0x86, right? So basically, to turn on the LED or to program the port B or TRISB, you have to write into this address. Do you understand? So let me write a code and let me show you here. See here. So basically, pay attention. Okay, see what you are having. You are having one register with the name TRISB. Okay, then there is one more register with the name port B. So what is the address of the port B register? What is the address of the port B register? Let me represent with the hex number 0x06. And what is the address of the TRISB register? 0x86. Am I right? Cross check 0x86. So basically, you have to write whatever. If you are giving the direction, you have to write 0x00 into this register, or 0xff you will be writing here. You understand? So let's program this. How to do this? Pay attention. Let's say this is my main. Pay attention, everybody. Everybody pay attention. So I will be writing a data into the address, some address. So how to refer the address, people? Usually, how to refer the address? What do we need for the address? Come on, how to read or how to write from the address? How to read and how to write from the address? Yes, we need a pointer. Very nice, very nice. But again, if you see here, these register maximum data you can write in this register just a 8-bit. So let me take a pointer of type unsigned character and let's say star PTR, or let me give the name to the first pointer as a TRISB. Okay, just for the clear understanding. Okay, so what is the name of my pointer? TRISB. And to this pointer, let's assign the address as 0x86, which we got from the datasheet. And just to, so, but if you do the assigning now, you will get the warning. About you will get the warning. Just to avoid that, let me typecast here like this. Fine. Okay, so here what I did, I have a I declared the pointer, which is nothing but the tris. Okay, and what address my tris pointer is having? It is having this address 0x86. It is pointing to this address. Great, nice. Okay, let me take one more pointer for the port B, or let me take one more pointer. Let's say unsigned character star port B. Okay, and what we are doing, what we are you doing, what is this unsigned character is what, Bhupinder? Unsigned carries the data type only, am I right? Let me assign the address 0x06, correct? And here if you just assigning like this, you will get the warning from the compiler. Let me typecast to the unsigned character star, or for a moment if you're getting confused about this typecasting and all, let me delete it. Let's have a warning, no problem. So let's just say I'm taking the pointer and I'm providing the address as 0x06 for what, for my pointer port B. Okay, here it is port B, and it is pointing to which address? It is pointing to the address this one. Fine. Okay. Now fine. Now let's write 0x00 to this address, to this pointer. So how to write a 0? Just what you are doing. You are dereferencing the pointer, and whatever data you want, you write it. Okay, so let's say I have a tris B. So let me just dereference star of tris B. Okay, and what I'm writing? I'm writing here what? 0x00. Fine. Then what happened to the next address into the port B? What I wanted to write 0x00. So how to refer this address? Just dereference the pointer. What is the name of the pointer? Port B, and I'm writing 0xFF. Done. So if I'm running this code in my microcontroller, what happened? Now it is going to turn on the LEDs of the port B. Answer is definitely yes, it will turn on. Okay, understood everybody? Understood how we are accessing the address, how we are assigning the addresses to the pointer, and how we are writing to that address. Now I got a question, why not integer? See, Gilraj, see how much data you can write in the register. Just 8 bits maximum. How much data you can write in any microcontroller register? 8 bits. So whatever data type of pointer is there, what is the usage of data type of pointer? May I know in simple term, what is the usage of data type of pointer? What is the usage of data type of pointer? So data type of pointer is saying that how much data that pointer is accessing in very simple terms. So since I will be dealing with just 8-bit data, that's why I'm saying character. If you have a 32 bits of data, then you can go with the integer, no problem. So like this way, we are assigning the addresses and writing the data to that address. But if you ask me, or if you answer honestly, don't you think this look very difficult to do? Don't you think it looks very difficult to do? Means right now you have a just a 2 register, that's okay. But tomorrow you have a 10 register, 20 register. Then are you going to see the addresses of each and every register? Going take the pointer, going to assign the addresses? Do you? Don't you think it is very difficult? Correct? So what we can do? Let's use the another approach. So we will not be using this. So what we will be doing, we are taking another approach. What? So if you observe here, am I adding any header file? If you observe my code, I am adding any header file? No. Let's include the header file. So we have a header file hash include xc.h, and in that header file, whatever addressing just now we did, all is already done. So what you will be doing, so you will be just using the names of the registers and port as mentioned in the data sheet, and you are done. Now see, you wanted to write in the Trisby, just use the name properly. It is case sensitive. If you are using the small letters or different namings, it will not work. So whatever name they are mentioning in the data sheet, refer it correctly and write it, and you are done. If you want to write it in the port B, just simply write whatever it is. Easy, very easy now. So what I did, I just added the header file, and in this header file, whatever definitions regarding the pointer addressing or whatever addresses we assign for the pointer, that is done in this header file already. So no need to repeat that, no need to done again and again. Just what you will be doing, you are including this header file and simply use the names as it is. That's it. Don't you think much simple now? Much simple now? Easy? Very easy now? Just add the header file and start programming. We are done. See, what is my code here? How to update this? I will be adding the header file hash include what it is xc.h, and just no need to declare anything, just done. Whatever I written here, Rahul, this is correct way. This pointer, this macro actually, which is already declared, defined in this header file. Don't worry about that. Just use the names as it is mentioned in the data sheet. So if you see the data sheet here, if they are talking about the port B, if they are saying that You have to program port B and the trace B. Use the names as it is, and you are done. Now, much simple approach, right? Everybody, very much simple approach. Done. So everybody, we completed our first embedded system program. We are done with that. So now don't worry about the previous approach, leave that. So just I wanted to tell you the importance of header file. If you include the header file, how easy things are, or why we are writing this way. Just to prove my point, we were doing the previous coding. Anyways, we are not going to do that. We will be using this approach file. Now what we will do, so now whatever time we are having in our hand, within that time it's not possible to see the output by writing in the MPLAB ID and see the output on the Pixel. So let's stop here. In tomorrow's session, I will write this code in the MPLAB XID from the scratch. I will explain how to open MPLAB XID, how it will look, what are the different menus there, how to create a project, how to write this code in the MPLAB XID. I will explain that in tomorrow's session, and even later we will open this board PiximLab, load the code here, and even we will see the output in tomorrow's session. So you have to be little patient. So tomorrow at 7 p.m. we will start with the seeing the output on our simulation board, or practically we will see whatever theoretically we discussed, it is matching it or not. Fine, understood? I hope whatever doubts you had in your last class regarding the LED programming, I hope all the queries, all the doubts are clear. So that's it for today. Thank you, everybody. So if you don't have any doubt, if you don't have any query, you can leave the session. If you have any questions, let me know. Thank you, everyone. But do attend tomorrow's session. Yeah, happy Janmashtami, Uday Kumar. Happy Janmashtami to everybody. Thank you. Have a good day to everybody. Thank you, everyone. So shall we stop here? If you have any queries, you post your queries in the discussion forum. So I made of things very easy now. This approach is very fine and very easy. So on the simulation, we will see the output in the tomorrow session. And those who missed, yes, Bhupender, now things become very interesting. Even from here onwards, things will be more interesting. Tomorrow is what? Tomorrow is a Saturday. Tomorrow class is there, Baba. Thursday, tomorrow session is there. Yes, lastly you understood the concept. Yes, because see, if see I'm not able to read your name. You're saying that lastly I understood the concept. See, if I explain this program at the start, are you able to understand anything here? No, it will be like bombardment, right? Okay. Portros we are not using. We are using Pixel Lab and MPLab XID. There is no holiday tomorrow. What is the reason for holiday? Is there any festival today? No, you have a class, people. Other than this one, Ganesh Chaturthi, there is no holiday. Fine. Shambhavi, please put your code query in the discussion forum. So the respective person will reply for your concern. So I don't know much about the offer letter. So you just put your question query in the discussion forum. I will forward that to the respective person. Fine. Chalo then, be there in tomorrow's session. Thank you, everybody. Good night. Good night to everyone. Thank you. Yes, Gopinath, what you are confirming? I think I answered your question. I don't remember. By 26th, Chetan, we will finish it. Result actually, guys, regarding your test result, as per the policies, we will be opening the test results, all the test results at the end of the internship. You will be able to see all the result or entire performance of your internship at the end once you did the submission and all these things. Fine. So, yeah, you can see that as of now, whatever you studied regarding this board, port B is used for the LEDs. Okay, port B and port D. Yes, correct. Tomorrow is no holiday, Gopinath. What is there tomorrow? Tomorrow class is there, no holiday. We are doing what very, we are utilizing the time properly. So there is no holiday tomorrow. Fine. I hope things are interesting. Chalo then, shall I close the session, everybody? Yeah, thank you everyone. Good night. If you have any query, please post it in the discussion forum. Thank you guys. Thank you, Giriraj.